If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in intermediate level where you are solving previous year JEE Main questions on method of differentiation. So in this lecture we will be solving question number 7, 8 and then 9. Okay, then let's see this. Question number 7, what they are asking: fx equal to sine of sine x, f double dash x plus 10x f dash x plus gx equal to 0. This is also a proof type, what we have done in basic level, but here we have to find out what value of gx it should be, or gx equal to minus f dash s plus 10x into this one also you can do. So what f is given of sine of x, and what they are asking, f double dash plus 10x f dash is equal to plus g is equal to 0. So you have to find g they are asking. So g is equal to minus f double dash plus 10x into f dash. So that we need to find. So what is f dash? Differentiation of sine is cos sine x, and then inside this sine you have to again differentiate, so this is cos x. So what is f double dash? Differentiation of this one, again u into v. First if you take this cos x constant, then differentiation of this one. This one, when you start, first you will do this one, cos is minus sine, then you do this inside sine, that is again cos, plus, now this is constant cos sine, differentiation of this cos is minus sine. If you open this bracket, it will be minus cos square x sine of x minus sine x cos of sine of x. So therefore what is g? G is equal to minus this one. So if you put these values here, minus of f double dash minus cos square x sine of x minus sine x cos of sine of x plus 10x, I am writing everything in sin x cos x, that's why I am writing 10x by cos x, and then f dash. What is f dash? Cos of sine of x into cos x. So this get cancelled. So if you see this one, sine of cos, sine cos sine is going. So ultimately things you are left with cos square x sine of x. That is your option D. So in question number 8, it is asking x is equal to under root a sine inverse t and y is equal to this, then find 1 plus dy dx whole square. So you have to find dy dx, it is parametric form, so you have to find dy dt and dx dt. So you have to write separately x is equal to this and y is equal to under root a to the power cos inverse t. So if you calculate dx dt, what will be dx dt? So root 1 by 2 root, differentiation of root sine inverse t, then differentiation of a to the power sine inverse t, that is a to the power x, so a to the power x log a, then differentiation of sine inverse t 1 by under root 1 minus x square. So this is the dx dt. Similarly, if you do dy dt is equal to 1 by 2 root a to the power cos inverse t, then a to the power cos inverse t into log a, and differentiation of cos inverse t is minus 1 by under root 1 minus x square. X is here t because we are differentiating with respect to t. So therefore dy dx will be equal to dy dt divided by dx dt. So if you do divide this one, log a will get cancelled. So ultimately you will get it. So if you divide these two log a and 1 by t square, these will get cancelled. Ultimate thing, you will left with all this. A to the power sine inverse t, here a to the power cos inverse t, and divide by under root this, and this will go upstairs, and all this will get cancelled. So that means minus of this and this will give you 1 by root in the a to the power sine inverse t divided by this, and this will again cancel. Root 2 by 2 is root 2, so this will be root a to the power cos inverse. Ultimately you will come to this position. So therefore then they are asking you now dy dx whole square 1 plus. So 1 plus this whole square means this root and this will go on. So it will be a to the power cos inverse t and a to the power sine inverse t. So now what is a to the power cos inverse t and a to the power sine inverse t? This is 1 plus x square and this is y square, because all your options in x and y. So finally we are replacing everything with x and y. So actually it is dy dx, so y term will get first, but just reciprocal of that one. What we have done? We have done this mistake. We have done actually dx dy. We have divided dx dt by dy dt. So at the end you just change it. So it will be inverse of this one. So it will be inverse of this one, because what we have done dx dy, we have divided this by this. Actually it should be this divided by this. So it will be 1 plus y square by x square. So it will be x square plus y square by x square. So therefore it is option D. So in question number 9, y is equal to fx this. So fx equal to x square minus x by x square plus 2x. Where x is not equal to 0 they have given, and x is not equal to minus 2 also. Then find ddx of f inverse x. So for finding inverse, how to find inverse? I told you, you replace the value of x and y in the inverse function we have told you. Graphically, what is inverse? You take the image on y equal to x. You have a graph, you take image of this one, that is the inverse of this one. And in algebraically, you change the position of x and y. Suppose this is my y. So this one will be x, this one will be y square minus y by y square plus 2y. Here you can take y common also, y minus 1, because they have given already x is not equal to 0. You could have cancelled also x, and it is y plus 2y. So you can cancel this y. Your intention is to write y equal to x in this format. That is your idea. So if you take out this y, so it will be yx plus 2. Yx plus 2x is equal to y minus 1. Or your y, if you take this side, x minus 1 is equal to minus 1 minus 2x. Or y is equal to 1 plus 2x by x minus 1. So this is your inverse function actually. If you change the position x and y, find y, this is your inverse x. So find differentiation of this f inverse x. So if you do differentiation, v square, v constant, differentiation of u is 1, minus u constant, differentiation of v is 1. So ultimately you will get 2x get cancel, minus 2 by x minus 1 whole square. Minus 2 minus 1, oh sorry, minus 3 by x minus 1 whole square. So that is your option D. Sorry, this is question number 9.
If you like the video, then press the like button and please give your valuable comments in the comment section.